So far, if you recall, in the previous session, we talked about the convolution operation, right? And the convolution integral, right? So the convolution integral is defined as y of t is equal to integration minus infinity to infinity x of tau h of t minus tau d tau. Okay, this is called convolution integral. And so the convolution of input and the impulse response gives the output. Okay, so y of t is equal to x of t convoluted with h of t, right? And then we applied it to some basic equations like this, that x of t is equal to u of t and h of t is equal to e raised to minus t by rc into u of t. If that is the case, then what will be the y of t? And then we found that the y of t is given by rc into 1 minus e raised to minus t by rc, right? This is exactly the charging waveform for the capacitor, right? Whenever you want to, you are charging the capacitor with a DC supply, then the waveform, that is voltage across the output, will look like this. Similarly, we did another example. Okay. Okay. So x of t is e raised to minus t and h of t is e raised to minus 4t u of t. Then also we found the convolution integral and we found the final answer like this. Okay. Now today we will see the graphical procedure for the convolution. So most of the times you will be asked to perform the convolution using graphical procedure. Okay. Now the graphical procedure is actually more systematic. Okay. It is more systematic than the rest of the procedures. Using graphical procedures, you can find out the convolution of any complex waveform. Fine. So how do we perform the graphical procedure? Okay, for the convolution. So let us assume that the input of the system is given by x of t, u of t plus 2. And h of t is u of t minus 3. Fine. So for the given signal x of t and h of t, by the way, the convolution integral is given by y of t is equal to integration minus infinity to infinity x of tau h of t minus tau d tau. That means you are going to draw x of tau, then you need h of t minus tau and d tau, right? Fine. So for that, you need to draw x of tau and h of tau first. Fine. So here we draw the h of tau and x of tau. So how do they look? Let's see. So first of all, we will draw this x of tau. Fine. So here we will draw the x of tau. Now it is not x of t, it is x of tau. So x of tau will be given by u of tau plus 2. There is a change of variable, okay? We are replacing t by a dummy variable tau. So you have x of tau, which is equal to u of t tau plus 2, and h of tau, which is equal to u of tau minus 3. Right? Now u of tau plus 2 can be drawn like this. Okay. This is u of tau plus 2, where here it is minus 2, here is 0, and it's tau. Fine. Whereas the tau minus 3 is given by this. This is 3. So this becomes u of tau minus 3. Fine. So this way, we plot x of tau and h of tau. Now, second step is, you may also write down, keep the function x of tau fixed and visualize the function h of tau as a rigid wire frame and rotate or invert this frame about vertical axis to obtain h of minus tau. Okay. So what does it mean? Keep the function x of tau fixed. That means don't do anything with x of tau. It will remain as it is. Okay. And then rotate or flip h of tau with respect to y-axis. Okay. So here we have h of tau So you need to perform h of minus tau, right? So how do you perform? How do you get h of minus tau? So it is very simple. Rotate it with respect to y-axis. So look at the original signal. H of tau is equal to u of tau minus 3. Whereas here, the h of minus tau will be equal to u of minus tau minus 3. This is h of minus tau. And I hope that all of you are drawing also. Okay. So have you drawn this? I'm giving you 2 minutes to draw this. Second step of graphical procedure is to keep the function x of tau fixed and visualize the function h of tau as a rigid wire frame and rotate this frame about the vertical axis. So you obtain h of minus tau. Okay. Try to understand. This is h of tau, which is equal to u of tau minus 3. Then h of minus tau will be u of minus tau minus 3. Okay. So only the sign of tau will change from tau to minus tau. Nothing else changes. Done? Okay. So h of tau is obtained. Now shift the inverted frame along the tau axis by t second. Okay. That means this actually starts at -3. Now shift okay, so what will I do? I will shift the inverted frame here. So once again, draw the same graph. Fine. Draw the same graph. And then this waveform is shifted by small t. Fine. This waveform is shifted by small t. So here we got h of minus tau. Instead here we will get h of t minus tau, which is equal to u of t minus tau minus 3. Or you can also say that u of t minus 3 minus tau. So it is shifted by t minus 3. This is h of t minus tau. Okay. We are shifting the h of minus tau by t seconds. Okay. Now t, small t can be any variable here. It can be any value here. Understand? So I hope you have drawn this. Have you done it? Okay, I got response from 2 students. What about others? What about other students? Rohit, Vijay. What about others? Rohit, Vijay. ये बताओ जो yes, Ashala. T means it's a time shift by some unknown value t. Okay. Normally, so far, We have always done the time shift with a known variable. Either you shift it by 2, shift it by 1, but here we are shifting it by small t. Okay, so it's a time shift. Fine. So now we have t minus 3. Okay, now the next step, that is step number 4, is to plot the graph for x of tau and h of t minus tau on the same axis. Okay, so what does it do? Let me show you. Okay, so here this t minus 3 is shifted leftmost. Okay, so that means this t minus 3 is at present, it is here. This was h of t minus tau. Whereas on the other hand, fine. On the other hand, we already have x of tau. Just a minute. I think I need to close this program. I need to close this program and open again. Okay. So this is x of t, x of tau, sorry, not x of t minus tau. This is x of tau. This is minus 2. X of tau is equal to u of tau plus 2. We have drawn x of tau and h of t minus tau on the same axis. Okay.
Hello, sir.
Why do we need to do this? Because if you recall in the equation, we had minus infinity to infinity, x of tau, h of t minus tau, d tau. So that means we need to multiply x of tau and h of t minus tau. If you want to multiply x of tau and h of t minus tau, both should be on the same line, so that we can see whether its multiplication is valid or not. Now in this case, what will happen if you multiply x of tau and h of t minus tau? What is x of tau and h of t minus tau in this case? Can you tell me? What is x of tau and h of t minus tau? Yes, I'm expecting answers from you people. Okay, let me ask an individual person. Rohit. Rohit, tell me what will be the product of x of tau and h of t minus tau in this case. No, not y of t. No. I'm asking you about the product of x of tau and h of t minus tau. What will be the product? What will be the product? Ashala is saying 1. See, look at the waveform carefully.
Zero.
It is 0, right? Why? Because these both are, when this is 1, the other signal is 0. When this one is 1, x of tau is 1, the other signal h of t minus tau is 0. So when at a time, both are not having finite value. One is having 0 and other is having 1 value. So the product will always be 0.
Hello, sir.
Yes.
Sir, could you allow us to join? We are in the waiting room.
What?
Could you allow us to join?
No, I will not allow anybody to join after 10 minutes.
Sir, just you didn't share the link on Telegram.
I don't want argument in the middle
of the,
I don't want argument in the middle of the session, right? You should have joined before 12:05.
You didn't, no link. How can you get the link, sir?
I have already shared the link in group.
No, you didn't share that on Telegram. We also make sure that we are not using WhatsApp anymore. Many people, many students are not using WhatsApp.
One thing, you are supposed to join physically, yet you are joining online, right? I have told you this 100 times that you join class physically. You are in the hostel, so you are supposed to come to the class physically. You are not joining physically. Second, that you are complaining that you are not getting the link when I'm already sharing the link in the group, right? And then now you are joining late and you are giving an excuse. I will not accept that. Okay. If you are so keen to attend the session, please come to the session on time. That is at 11:55 or at most 12.
You can check the Telegram group if you want.
Yes, I have not posted it on Telegram group. I know that. I know that. Fine. Now the second case is that when x of tau and h of t minus tau both overlap. So here we have u of tau plus 2, that is x of tau. And second, we have, let's say, this is t minus 3. This is minus 2. right? Now, there is a multiplication possible. Fine. Multiplication is possible, but it is only possible from -2 to t minus 3, like this. Okay. What I have done, see, what I'm trying to do here is that I take this waveform, right, which was earlier, it was here, right? And because I can vary small t, so I'm varying the small t such that there is an overlap, finite overlap, right, between -2 and t minus 3. So t minus 3 is variable in the graphical procedure. Now, if you see, then in this case, x of tau and h of t minus tau provides 1, but only from -2 to t minus 3 range. Fine. So the product is 1, but only from -2 to minus t minus 3 range. Fine. Okay. Now the next step, as I said, you need to shift for the particular value of t is equal to a. Now here I am taking this t minus t minus 3. There is some value of t which is equal to a. The integration of product x of tau and h of a minus tau represents the area under the product curve, that is the common area. This common area represents the convolution of x of t and h of t. So if you find out the area under this curve, right, that is the convolution integral. Fine. Okay. Now, when you do this, you may come up with some different cases. Okay. Okay. Now, can somebody tell me when this two curves, x of tau and this is h of t minus tau, when will this start coinciding? Can anybody tell me? For which value of t these two will start coinciding? See, when the curve x of t minus tau is at here, so this is t minus 3. When it is here, at that time, they both start coinciding. Get it? Is it clear, or anybody has any question? If you have a question, please put it in the chat box. Any question? Okay, so I was asking you that for which value of small t minus 3 you have just started the getting the overlapping. Okay, for which value of t minus 3 it starts overlapping. So then you can find out as t minus 3 is equal to minus 2. That means t is equal to 3 minus 2, which means t is equal to 1. So for value of t equal to 1, it starts overlapping. Understand? So the minimum value of t should be equal to 1. Understand? Understand or not? Understand this point? You need to find out the value of t, small t, such that both curves will start overlapping. Okay. So see, we have drawn two cases here. One in which there is no overlap, and second in which there is some overlap. Okay. But if you shift this curve up to this point, this is the point where the overlapping has just started. Okay. So that is the t minus 3, the upper value should be equal to minus 2, right? And then you can start increasing the overlapping area. You can go up to, right, like this. Okay. So is it clear now? Okay. So minimum value of t is 1. Okay. Now increase the time shift and take the new interval where the function either x of tau or h of t minus tau changes. That is only this one. Okay. So here we have increased the time shift. Okay. Here we have increased the time shift such that there is a definite overlap, right? Okay. Now, if somebody asks me that, okay, that from this, can you find out y of t? So I would say, yes, y of t is equal to minus infinity to infinity x of tau h of t minus tau d tau. Now, instead of minus infinity to infinity, I will put minus 2 to t minus 3 x of tau h of t minus tau d tau, right? If you take the area, if you want to take the area, then minus 2 is the minimum limit and t minus 3 is the maximum limit, and this is the amplitude. Fine. So then we can take y of t is equal to minus 2 to t minus 3 u of tau plus 2, sorry. So it is u of tau plus 2 into u of t minus tau minus 3 into d tau. Now for minus 2 to t minus 3, this value is 1 and this value is also 1. So now you get this equal to minus 2 to t minus 3, 1 into 1 d tau. That means it is equal to tau, where the lower limit is minus 2 and upper limit is t minus 3. So you put the value, substitute the value, so you get t minus 3 plus 2. And hence it becomes t minus 1. So y of t is equal to t minus 1. Okay?
Hello, sir.
Yes?
Can you show explanation number 5 and number 6? I just want to take note.
Okay. See, 5 and 6 together, they are taken like this. Now, see, in this case, 5 and 6 are actually merged almost, right? But in the coming sessions for different functions, so this 5 and 6 may have their own significance. Okay. So 5 is that for a particular value of t is equal to a, integration of the product represents the area under the product curve. Okay. Now, so you take some value of t which is equal to a. 6 is that increase the time shift t and take the new interval whenever the function changes. So that means we are changing constantly. We are changing the h of t minus tau, and this particularly the value of t, small t. Okay, the value of small t, so that the interval, okay, changes, and so the area, right? Now let me show you this with the help of a small animation, and I'm sure that you will get to you will definitely understand what I'm trying to say here. So for example, see here, this is t minus t, and here it is h of t minus tau. Understood? Okay. We are drawing here this x of tau. This is x of tau, and this one is h of t minus tau. This one. Okay. Now, I want to change value of t. Can you see this? I'm changing the value of small t here. Okay. And how, look at how the area under the curve changes, and so the amplitude also changes. So this vertical bar lines that you see here, okay, which is in the form of a line, this is basically your output t minus 1. Understood?
Check podium convolution.
Sorry, sir. Okay. So this simulation or a kind of animation, it was developed using GeoGebra or app. There is one app called GeoGebra. Okay. So for any mathematical function and its evaluation, graphical evaluation, you can use this app. So now you can see that how the value of small t changes, and with that change, how you are getting the output. Now you see so this is the output. Now you can see that the output starts whenever this h of t minus tau comes at -2. Now it starts. Okay. But it is basically a ramp waveform with a function t minus 1. Understood? This is already there. This simulation is already there in Canvas. So if you wish, you can later on verify this. Fine. Okay. So going back to our discussion, this is R of t is equal to t minus 1, or you can call it y of t is equal to R of t minus 1. So this is the answer. This is the final answer, right? And how do you draw the output? So the output is drawn like this. This is the output. This is 1. And here your example ends. So I hope you are able to understand everything. Okay. Let us explain the entire procedure again. So let me explain this. So we started our session with graphical procedure for the convolution. The example was taken as x of t is equal to u of t plus 2 and h of t is equal to u of t minus 3, right? X of t is an input to the system and h of t is the impulse response of the system. Okay. First step is that for the given signal x of t and h of t, you need to replace the independent variable small t by the dummy variable tau. So now we will plot the graph for x of tau and h of tau. X of tau is equal to u of tau plus 2. So the waveform for u of tau plus 2 is drawn here. Then h of tau is equal to u of tau minus 3. So waveform for u of tau minus 3 was drawn here, right? After that, the second step was to keep the function x of tau fixed and visualize the function h of tau as a rigid wire frame and rotate this frame with respect to vertical axis. That is tau is equal to 0. So you obtain h of minus tau. So h of minus tau is just the mirror image of h of tau. Then you shift the inverted frame along the tau axis by small t second. Okay. When you shift it by small t second, then the shifted frame now represents the h of t minus tau. Right? So here h of t minus tau is drawn. Right? It starts at t minus 3 and it goes up to infinity. Right? Whereas the amplitude is 1 only. Now, next is plot the graph x of tau and h of t minus tau on the same axis, beginning with very large negative time shift. That means here. Okay, beginning with very large time shift, such that both will not overlap. So as a result, as you can see, that the product of x of tau and h of t minus tau becomes 0. Okay, because we need to find out the area under the curve, integration of the product. So first we need to find out the product. Product is 0 in this case. Next step is, for a particular value of t is equal to a, the integration of the product x of tau and h of a minus tau represents the area under the product curve. Right? So you choose a value of small t such that they start overlapping. Okay, then there will be a common area. This common area represents the convolution for the given time shift. Now I have increased the time shift t, and then I take a new interval wherever the function x of tau and h of t minus tau change. Okay. So now we get a definite amount of interval for which both the outputs are overlapping, or both the signals are overlapping each other, right? Then you apply the convolution integral. So y of t is equal to integration minus infinity to infinity x of tau h of t minus tau d tau. Fine. And then you put the value of x of tau and h of t minus tau in the integral. So finally, you will get the output. When you evaluate the integral, you will get the output. Okay. And I hope that you don't have questions now. In the next session, we will start with some other example and then the convolution property. Fine. Now all of you enter your enrollment number in the chat section.